Hi everyone. So today we are going to solve a problem that is generally asked in machine learning system design interviews. That is personalized newsfeed recommendation system. Before jumping into the video, I want to tell what I'm going to cover in this video. So I'm going to cover about the objective, that what we are going to build. Second is the input and output to our system. Third will be the data engineering part, that what data do we have with us. Fourth would be feature engineering part, where I'll tell you how are we going to exactly use the data to convert them into features so that our model can use it. Fifth is the model development part, where we are going to cover that what uh, exact model we can use, or what kind of model we can use to build such a system. Sixth will be evaluation. In evaluation, both kind of evaluation, offline and online, that once your system is made, how are you even going to tell your system is good or is it bad? And the seventh part is the serving part, where how are you going to so it's not just like making a simple model, you need to serve it to the end user. So how the whole system needs to look like, I'm going to cover that as well in the last part. Now coming to the objective. The objective is pretty straightforward here. We need to show unseen posts to the user which are relevant to a particular user. Okay, but how are the posts going to look like? The post could be like an image, a text, video, just like how your Instagram or LinkedIn works, where you just post it like a text plus video, text plus image kind of stuff. In the same way, our post is going to look like. Third thing is that here the user can like a post, comment over a post, share a post, uh, hide a particular user, block a particular user, and even can send the friendship request as well, as we do over such kind of platforms like Insta and LinkedIn. Fourth is that we also need to make sure that we need to increase the engagement on the platform. So if let's say today there are X number of users on the platform, and they are seeing the platform for let's say Y hours, we need to increase the engagement, means we need to make sure that they see it for more number of hours, so they spend more time on that. So we need to make sure that increasing the engagement. Okay, and this is the major objective that we are going to cover. Now coming to the next part, that what is the input and what is the output of the system. So here input would be just the user itself, and this is our system. Let's call this recommendation system, and the work of this is to show unseen posts to the user which are relevant. Now at rank 1, we are going to show post which is the most relevant, and as we go below, the post will be less relevant to the user. And like we are just going to show top 20 posts. We can choose any K, like top K post. So for K I'm choosing 20 right now. So this is the input and output of the system. Now coming to the data engineering part. So in data engineering part, if you think like what exactly data do we have with respect to the platform. So think like if you are using Instagram, so what data do we have? So first thing is that the user data. So first data is related to the user. What data do we have with respect to user? We would have a user ID. We would have the age of the user. We would have the gender of the user. We would have the location of the user. We would have the preferred language of the user. And I guess these many things are generally which we have, but we can have some other things as well with respect to a user, that okay, what kind of post did the user like. So list of posts which the user liked. Similarly, he could comment over a post as well, so we could have a list of that as well. And similarly, list of posts which the user shared. Okay, these many details we have with respect to a single user. Okay, what other data do we can have? We can have data with respect to a post. So as soon as you post, what generally you have? So you have a post ID. Then second thing is image or video that is there with the post. Then comes if the user has put a caption or a textual comment or some text along with the post, so we will have that. So textual content. Then generally we see that there are hashtags always there with post. Then comes like the age of the post could be also there. Like, so for example, if a user is posting something today, so it's just fresh post, right? But if it's like posted 7 days ago, so this could be also one thing, age of the post. Then comes the next thing, that could be likes over a post, comments over a post, shares over a post. So these things could also help us in feature engineering, that okay, if there are multiple likes over a post, and like there are like millions of likes over a post, so it means it's a popular post. And if there are millions of comments on a post, it means it's a really popular post. We can show it to a user. So these many things we have with respect to a post. Okay, what other thing we can have? We can have some other things as well, such as user author affinity. So what does this mean? Okay, so we can have user author affinity, sorry, not affinity but friendship details. So what does this mean here is, see, there are two users. So either a user could be a close friend of the other user. This is one thing. So even in Insta we see this, there's this feature called as close friend. So we can have something as such as a detail, because users are more prone to see a post which is posted by a he's more prone to see or like a post which is generally posted by a close friend, right? So we can have such details. So in this we can have like a particular user ID is a close friend to a, so there could be two user IDs here. Either they are close friend or not. If yes, then it's good. And what time did their friendship start? So time when the friendship started. Now why is this important? Because if let's say you have this data where you have a friend which is from the past 10 years, so if he posts, so you are generally going to like or comment over his post. So we need to show these posts at the top, right? So this is something which we have right now in our data. Now we are going to use it to convert them into features, but how are we going to do that? Let's see. Coming to the fourth part, that is the feature engineering part. So in feature engineering, the data which we have is, let's say the first data we take with respect to post, that how do we convert this post into something which we can use later to train our model. Okay, So if you see here, so here we had our features. We have our data related to multiple things like user, post, and user author friendship. So how do we convert them into features that can be used by our model? So here we have uh, data with respect to post. So let's see how we will be converting them into proper features. So see, at the end, what do we want is that we want that if a post which is related to cricket should be kept close to a post which is related to cricket, like the posts which are related to sports should be near to each other, and the posts which are related to, let's say, travel are related to are kept closer to each other. So for that, the simplest thing is that we can think of something like embeddings, right? So somehow we need to convert this whole post stuff into embeddings. Now how we are going to do that? So we have this post ID. Now we have around 5 million posts, like there will be roughly 5 million posts over our platform. So the data is like really large, right? And if we need to convert this post ID into something which is meaningful, the best thing is that we need to convert them into embeddings. Now what should be the size of the embedding vector that we choose? That is the question. So generally there is this rule of thumb which is minimum of n comma minimum of 50 comma square root of n. So what does this mean is that so if we have 5 million posts, so roughly the embedding dimension should be minimum of 50 comma square root of 5 million. So it would be roughly boiling to 50 only. So we can represent a particular post using a vector which is of 50 dims. Okay, and once the model is trained, this will be eventually learned. So basically what will happen is that if a post is related to a cricket and there is another post which is related to cricket, they both will be closer to each other once back propagation happens and all the model is trained. Okay, so this particular thing is represented using a 50 dim vector. Now we have image video. Okay, so for image video, the best thing that we can use is we can use a pre-trained model to convert it into a vector which has the semantic meaning of that image or video. Okay, so for example, for image or video we can use this for images we can use this model called as clip and convert it into a vector which is, let's say, 256 dim in nature, 256 dim size, right? Then comes textual content. So what does this textual content mean? So for example, whatever caption we are writing, right, we need to cover the semantic meaning, what the user wants to write in the post, or what the user want to explain in that post. So for that as well, we can take a pre-trained model and convert it into a vector which covers the semantic meaning. So here for textual content also we can take a 256 dim vector. Now coming to the hashtags. Now there could be multiple hashtags present in the post, right? So what we can do is that a hashtag could be passed through a pre-trained model like GPT-2 or BERT and converted into a 50 dim vector. And what we can do is that we can take average of all of them. So for example, there are multiple hashtags like cricket, hashtag Virat Kohli, something like that. All of them could be passed, so it will generate a embedding which is of 50 dim. It will generate an embedding which is of 50 dim. We can take average of all of them, which will represent all the hashtags. So here we can represent it using a 50 dim vector. Now coming to the part where age of the post. Now for age of the post, what you can do is simplest thing you can do is that bucketize plus one hot encode. What does this mean? See, So age of the post could be divided into like, so let's say the post was just like 1 hour ago. Okay, then post could be like 5 hours ago, then it could be like 12 hours ago, then it could be like 2 days ago, 3 days or 4 days ago, and then something like 7 days, and the last could be greater than 7 days. So we can bucketize we can divide them into categories. So for example, if a user which has posted recently, that could be presented using just a vector which is like, let's say 1 2 3 4 5 6 7. So just a 7 dim vector we can use, and we can represent the post like 1 0 0 0 0 0. So this is how a post could be presented. The age of the post could be presented. So we can use here bucketization plus one hot encoding. Now coming to the final thing, that is likes, comments and shares over a post. So for that, what we can do is that either we can use min-max normalization, or yeah, we can just simply go with the min-max normalization stuff to convert them into a single dim vector which represents a normalized quantity of the likes over the post, comment over the post and shares over the post. Okay, so it could be just like a three dim vector which represents the likes, comments and shares. Okay, now once you concatenate all of them, this is how a particular post could be represented. And at the end, you see post ID will be the one which at the time of backpropagation, the embeddings of this will be changed. Okay, now coming to the part where we have data related to a user. Now how are we going to use that? Okay, so for user, we had this data. Okay, so roughly how many users we can have? Let's consider that, okay, we have 5 million users for now. So representing every single user by 1 2 3 4 is not good, and neither our model will understand. We need to make sure that the users whose tastes are same, they are also need to be closer to each other. So the best thing is that we present this user ID into a vector. So here also we are going to use embeddings only. Now how are we going to do that? So see, roughly 5 million users are there, and we know that the rule of thumb says that the dimension of the vector could be square root of n comma 50 min of this. So here also this user ID could be represented using a 50 dim vector. Okay, now for age, what we can do is, so for age we know that the best thing is that we know there are multiple age categories. For example, 10 to 15 could be one age, then coming to 16 to 24, then coming to 25 to 32, 30 to 44, 44 to let's say 54, and then 54 to let's say 80. So you see that we can divide them into multiple categories, and if you can divide them into multiple categories, the best solution is that you use one hot encoding plus bucketization. So bucketization means that dividing into categories, and one hot encoding would be, so for example, if a user whose age is like let's say 22, it could be presented like 0 1 0 0 0 0. So here this could simply tell that, hey, the user's age is roughly between 16 to 24. So it could be simply represented using a 8 dim vector. Now coming to gender. Now gender has only 3 options, right? Male, female and other. Now for representing that, again we can use a 3 dim vector, where if let's say if there is a male, we can represent it using 1 0 0. If it's a female, we can represent using a 0 1 0, and if it's a other, we can represent using a 0 0 1, right? So here we can just use a 3-dim vector. Now coming to location. So let's consider that we have roughly 200 locations with us, right? So again, to represent locations, we can simply use embeddings. So we again apply the rule of thumb, that is square root of 200 comma 50 and the min. So that would roughly come out to be 16. So means this particular location vector could be represented using a 16-dim vector. Now the preferred language again could be represented using like embedding vector only, and here for ease of calculations we can just take a 8-dim vector. Let's consider that there are like 60 to 70 languages with us. So if you apply the rule of thumb, it would come to be 8-dim vector. Now for list of posts which the user has liked or commented, so how are we going to do that? So what we can do here is that, let's say user liked post P1, P2, P3, P4, right? And we had the embeddings for them. So the best thing is that what we can do is that this embedding was a 15-dim vector, right? So we can take average of all of them. So it can tell the taste of the user, that what kind of post does the user like. And similarly, this could be done for comments as well, and same could be done for shares as well. So you can take 3 vectors which represents, like, this will be a vector representing for likes, another vector which represents for comments, and another vector which represents for shared videos. Okay, now we have this data with us which is related to a particular user. We can have some other data which could be essential for us, such as device, what device the user is using. So what does that mean? So generally, if the user is on mobile, he has more chances to see the post which generally does not contain much information, right? He would generally go with information like a simple image, textual information, or textual information would be less, right? He would not apply all his brains seeing the post, right? And generally, when the user is seeing the laptop, he tries to see and read the whole post. So we can have this information, that what device the user is currently using. So let's consider this 6th thing, that is device. So it could be either mobile or a laptop. So if it's 2 categories, then it could be represented using one hot encoding. So mobile could be represented like 1, 0, and if it's a laptop, then it could be represented using 0, 1. Now this is something through which we can represent a user, but how are we going to exactly use that? I'll tell you in the model development section. Now coming to the part where we need some other information. Okay, we know that we somehow need to increase the user engagement, right? So we need some information that is that tells us that what chances are there that, hey, if a user can like a particular post, or what chances are there that if a user can comment over a particular post, or share a particular post. Okay, so somehow we need to convert our data into such a feature. So that could be said as user author affinity. What does this mean? So here, let's say I'll give you a small example. Let's say there is this user called as Rahul, and there is this another user called as Mohit. Now Rahul and Mohit both are friends, right? So and Mohit has posted like 10 posts, okay, and Rahul has liked 9 of them. So it means that whenever Mohit will post, Rahul will is going to like it. There are very high chances that Rahul is going to like that post. So we need such data that our model can use to predict that whether the user is going to like that post, comment over a post, or share over post, share a post. So what we can do is that we can calculate the like rate, comment rate, share rate, and the length of the friendship. Now, what does that mean? So, for example, if uh, the Rahul is liking 9 posts out of 10, so it means the like rate is 0.9, right? Then the comment rate could be like, let's say 0.2, or share rate could be really less, like 0.3, or and the length of the friendship could be something like we can use min max normalization here to represent into a one dimensional quantity, right? So and once we concatenate all of them, these 4 things could be used to tell how a particular user is close to another user. Okay, so we have this data with us right now. Now somehow we are going to use this data to train our model. Okay, but how are we even going to do that? What model we are going to use? That is the question. See, the thing is that rather than saying that, hey, the model is going to, hey, the user is going to, we are just going to show this particular thing to the user. Rather than that, what we can do is that let's try to predict that what are the chances that the user is going to like this post? What are the chances that user is going to comment over a post? What are the chances that user is going to share a post? Or what are the chances that user is going to hide this post? And once we get this, we somehow get a score out of them. And if the score is high, then we show this post to the user. And if the score is low, we are not going to show this post to the user. You can ask me one thing that, hey, does this make sense that like, comment, and share will have the same measure or same weightage? No, because uh, if the user is going to share a post, it has more weightage over something which is going to be liked. So the post which has to be shared should be shown at the top. The post which is going to be liked should be shown a little below, right? And if the post is like hidden item, it should not be shown. So everything will have a different weightage associated to it. Okay, so what model we should use? So see, what we can simply do is that rather than carrying out like making different models for calculating the like for calculating the like probability, for calculating the comment probability, for calculating the share probability, what we can do is we can use a uh, single network but with multiple heads. Now every head, what it is going to do is that it will try to predict a different thing. For example, let's say this is a neural network. And what it's going to do is that it will have a like head, which is going to tell that what are the chances, what is the probability that the user is going to like that post. Then comes comment head, then comes share head, then comes hide head. So everything is going to be a different, uh, every particular head is going to predict something different. And using this particular probability, what we can do is that at the end we can combine all the scores and then get a common score and try to see whether this score is high. And if the score is high, we are going to show this post to the user. If the score is not high, we are not going to show it to the user. Now coming to the question that what this kind of model is called. So this is a multi-shade uh, deep neural network. Now, why did I go with a multi-shade DNN? The reason is that all these like heads, comment heads could use the same layers. So the time for model training would be less as compared to something like if I choose different models for calculating different things. Now, if you are using a single model, you are going to do all the stuff. Okay. Now, coming to the point that how our model and how our data that we are going to use for training, how it's going to look like. Okay. So, see, we had user features, right? Then we had post features. Third thing we had was user author affinity. Okay, what we can do is that we can add columns which represent like why like means whether the user liked the post or did not like the post. Why comment, whether the user commented the post or did not comment the post. Then comes the why share, whether user shared the post or not. And one more thing we can do is that let's say we can try to calculate the dwell time. So what does this dwell time mean? Dwell time means the amount of time the user is spending watching that particular post. So for example, the user posted a post which is related to something like machine learning, and another user which is interested in machine learning will try to go through the whole post and he will try to spend some time. And let's say if the user is spending a lot of time, it means that we need to show him similar posts which are related to machine learning, right? So this is the data that we are going to have. Okay, but how our model will look like and what loss function which we will be using, let's come over that. So see, the model is nothing but a multi-shade DNN, right? And we have three things coming, that is user features, post features, and user author affinity. And then we have multiple heads which are predicting multiple things like head, which is predicting the like probability. Then we can have comment head, share head, hide head, and then there could be something like dwell time. Okay, now see, once we start training our model, we need to use a proper loss function. So the loss function would be something like so this would be for like head we would have loss L1. For this we will have L2, we will have L3, L4, and then L5, and the total loss would be L1 plus L2 plus L3 plus L4 plus L5. Now how are we going to calculate this particular loss for like? See, the thing is that you are just predicting, right, that whether the user is going to like this post or not. So it means that it's a classification based problem for this particular thing, like head, right? So if it's a classification based problem, the simplest thing that you can do is that the loss function could be binary cross entropy. Same goes for the comment head, and same goes for your share head, and same goes for your height head. Now for dwell time, see, for dwell time what we are calculating is the number of seconds or the number of the time the user is going to spend over a post. So it's a regression based problem now, right? So for regression based task, what we are going to have is the loss is mean squared error loss, MSC. Now coming to the point that final, so when you, let's say, train the whole model, what exactly will be trained, right? So the model weights will be trained, then you will have your user embeddings that are going to get trained, you have your post embeddings that are going to get trained, right, which we represented using 50 dim initially. They all are going to get trained at the time of back propagation. So we are quite sure that okay, we are somehow able to manage this particular thing, but you see, there is this problem. What problem we have is that, see, users generally go and like some post. For liking is very common, but sharing a post is very less as compared to liking a post, right? So that would eventually be a bigger problem for us. So how to deal with such a thing where the data with respect to sharing would be really less? So how are we even going to take care of that? Because you see, why, like, there would be multiple ones, but in why share there would be like many zeros, and there would be only a single one somewhere. So for that, what we can do is that, so in the loss function, when you are calculating the total loss, what you can do is that you can give weightage to uh, different things, like could have a loss as 1, share has 3, means you are just giving more weightage. So the total loss would be something like 1 into L1 plus let's say comment has 2, so 2 into L2 plus 3 into L3. So it means that for example, if a user if the model is giving a wrong thing, we for sharing, he is giving a wrong probability for sharing, we want to penalize the model more. So that's why we are giving this weightage as more, so that the model is penalized more. So this is how we are going to take care of this imbalanced data set here. Now one more thing is that how are we even going to take care of the problem of cold start problem? So what does this cold start problem mean is that if a new user comes and if a new post comes, how are we going to entertain that stuff? See, for new post, so for new post, what you can do is whenever a new post comes, you can show to some percentage of users, right? And once you show it to some percentage of users, what will happen is that you will get likes and comments over that post, and you will get some data with respect to that particular post. And once your model retrains, you will get a post embedding for that particular post. So now that post will be, so let's say the post was related to cricket, so the post embedding would be closer to the embedding of cricket post, right? So this is something which we can do with respect to a new post. But how are we going to solve this problem of new user? See, for new user, what we can do is that generally we can start with very simple things. We can show him the most popular post, okay, most shared post, okay, and some random post. Now how is this going to help us? once the user likes or clicks or any likes or comments over any post, or let's say share or hide any post, what we are going to do is that every other day we are going to retrain our model. So the user embedding is going to be formulated, and we will know that okay, this user likes such a content. Okay, so this is how we are going to solve the cold start problem. But how the exact design for this will look like, I'll cover in the serving part. Okay, now you have made this model, right? And once you have made this model, just to make sure, one more thing, how will you calculate the final score, that whether you are going to show this particular post to a particular to a user or not. So for that, we will assign weightage scores. Weightage scores means for like there could be a score of, let's say, 5. For share there could be a score of 10. For comment there could be a score of 8. For hide there could be a score of -1. So for example, what happened was, let's say our model gave this like probability as 0.8, comment probability as 0.2, share probability as 0.6, hide probability as, let's say, 0.1, something like that. So what we can do is that we can just do a 5 into 0.8 plus 0.2 into what was the comment score, 8 plus 10 into whatever was the share probability, and then we can get a final score. And if that final score is greater than our threshold, we can set a threshold score, and if it's greater than that threshold, we can show that post to the user. Okay, so this is how we are going to recommend a post to the user, and all the posts will be unseen. Now coming to the part where we need to evaluate this model. So for evaluation of the model, there are two things. First thing is offline evaluation. So what does this mean? See, offline evaluation means that you have made the model, but you are not going to make it live, so the end users don't see it, but you have the historical data with you, that how did the users liked multiple posts over a platform, or how did the multiple users commented over a particular post. All this data you have. Now on the basis of that data, you are going to see that, hey, whether my model actually works perfectly, or does it perform really bad. Okay, and second could be your online evaluation. Online evaluation means that hey, you have made this model live and the end users are seeing it. Now once the end users are seeing that, you are getting real-time data whether your model is performing good or not. Now how does this, first I'll discuss about online evaluation, and then I'm going to cover the offline evaluation part. So for online evaluation, see, simplest thing is that reaction rate. So for that, what you can do is that the reaction rate could be number of reactions on the post by total number of impressions on the post. So what does this mean? Let's say there were roughly 1 million impressions on the post, and out of which roughly 5 lakh people liked that post. So it means that the reaction rate was good. So it means that you are able to show relevant posts to the users. This is one thing, one criteria. Second criteria is very simple. We initially said that we need to increase the user engagement, right? So if we are increasing the user engagement, we can simply see that the amount of time user is spending over the platform in a week. Let's say if it's increasing. So if it's increasing, it simply means that we are showing a relevant post to the user. That's why it's increasing. Now coming to the second part, that is offline evaluation. So for offline evaluation, we can do two things. First thing is recall at the rate k. Now what does this mean? Let's say we showed 20 posts to the user. Let's say 20 posts to the user, out of which we know we already have this data, historical data, that the user liked 5 posts. Okay, so here, so in the historical data we know that user liked 5 posts. Let's call them P1, P2, P3, P4, P5, and out of these 20 posts, the only 4 posts were shown out of means, let's say the 4 posts that were shown were like P2, P3, P4 and P5, and let's say there are other posts like P750, P860, something like that. So here the recall score would come by 4 by 5. So it means that if the recall score is high, it means that we were able to show the post which were relevant to the user. Okay, recall at the rate k shows that whatever post we are showing to the user, are they relevant or they are not relevant, but it does not tell about the ranking quality. Now what does this ranking quality mean? See, ranking quality means that if we should always show post, top post should be something which should be really relatable to the user. The user has more chances to share that post or repost that post, something like that. So the ranking quality matters here. Now how do we measure this ranking quality? So for that we have something called as NDCG at the rate k. So what does this mean? This means normalized discounted cumulative gain. Now how is this calculated? I'll tell you that. So the score is the formula is pretty straightforward here, that is DCG at the rate k by IDCG at the rate k. So IDCG is nothing but ideal discounted cumulative gain and DCG is discounted cumulative gain. So what does this mean? So let's say now formula for DCG at the rate k is, if we want to calculate that, is relevance of I by log of I plus 1 summation for all the posts. Let me explain you with an example. Okay, let's say our model gave 5 posts, P1, P2, P3, P4, P5. Okay, now P1 was shared. So we had these 5 posts. Now let's say that with the data we have, we know that P1 was the post that was shared, right? P2 was commented, P3 was liked, and P4 and P5 were ignored, like there were no reactions over it. Okay, and we know that every particular reaction has a weightage associated to it. So share has a weightage that is 3, comment has a weightage that is 2, like has a weightage 1, and the other scores have a weightage of 0. Okay, but whenever we trained our model and we got the data, like let's say there is a user who opened the app and he got these 5 posts. Now these 5 posts were in a different order. The order was something like P2, P1, P3, P4, P5. Okay, now let's write their scores in front of them. So this has a score of 2, this has a score of 3, this has a score of 1, this has a score of 0. Now how do I calculate DCG here? the DCG would be calculated by, for this, the relevant score is 2 and the position at which it is. So it's at the position 1. So it would be written by 2 by 2 plus, log of 2. Then comes 3 by log of 3. Then comes 4 by log of 3 plus 1, 4. Then comes 0 by whatever position it is, plus 0. So let's say there is a score that comes out to be, let's not calculate the whole score here. There is some score that is coming. Now, how do we calculate this ideal DCG? So ideal DCG means that how the score should have come. Ideally, the score should have come like this, right? So it should have come like 3 by log of 2 plus 2 by log of 4 plus 1 by log of 3, 4 plus 0 plus 0. Okay, now what happens is that whenever you calculate these two scores and you divide one by the other, if your NDCG comes to be 1.0, it means you have made a perfect model. Like the model is giving really good ranking and showing the most relevant post at the top and the less relevant post at the bottom, right? And if it comes out to be 0.7 to 0.9, it means okay, we are able to show some posts which are relevant, means but it's slightly lower. And if it's less than 0.5, it means that hey, your model is not that good, you need to improve your model. Okay, now these are the two offline evaluations that we can use. Now coming to the last part, that is the serving. See, for serving, how are we going to take care of that? In serving, if you think logically, there should be two things. One should be a prediction pipeline, which predicts post, that what post are we going to show it to the user. And second should be something which should take care of your data preparation part. So the data will be coming every day, right? And every minute it will be coming. So for example, if a user logs in and he just reacts on 5 posts, it's coming every minute. So you need to take care of something which take care of this as well, this data preparation part. So one will be your data prediction pipeline, and second is going to be your prediction pipeline, which is going to take care of your of the part where we are going to show relevant unseen post. So see, the data prediction pipeline, how it will look like. See, the stream of data and new interactions is coming like almost every minute. Stream of data. Now see, there could be two things there. First thing is, we need to maintain two things. One thing is that what is the user's mood right now, and second is what is the user's personality in general, what the user likes and what is currently the user is liking. For example, let's say you open your Instagram and you start liking reels which are related to music. So you see that recommendations are also related to music in that particular session, right? So we need to take care of this. So here there will be a data store where the data is coming. Okay, there will be two things here, that is online feature computation second could be your batch feature preparation. Now what are these two exactly? I'll tell you. See, feature preparation takes care of all the data for taking care of your personality. Okay, and online feature computation is something which is going to take care of the things which are just on that particular session, that okay, what post are you exactly liking, like last 5 liked post, and what is the time when you are using your platform. So for example, if you are using it the night time, we will show posts that are less more soothing to you and less brain consuming for you. Okay, so this will take care of your online feature computation, and this is going to take care of your batch feature computation is going to take care of your personality features. That hey, in general, this user likes posts which are related to technology or something which is just related to artificial intelligence. Okay, so all this batch feature computation stuff gets stored in a feature store. Okay, this feature store is nothing which is something which is taking care of your whole personality in general, what does the user likes. Now somehow we are going to use these two things to predict relevant post to the user. How are we going to do that? See, for example, so let's say a user comes. Okay, now the first thing is that we have 5 million posts. Now we can't apply the whole ML algorithm over 5 million posts and check, hey, the user is even interested in this post or not. So there should be something which decreases the size of post. Okay, so that is called as retrieval services. Now what does this retrieval service actually do? So this retrieval service will make sure of few things. First thing is that pure logic, business logic. For example, I need to show posts which are related to user's language. I can't show him posts which are spoken in another language, right? So there are some business ML logics, like pure logic that needs to be applied here. Then second is that we are going to show him posts which are related to a particular region, not something which is like really far away from here. So if I see posts which are which is somewhere from Brazil, I would not be liking it, right? Like it's really far away from here. So location related. So these are just some kind of filters that are acting at the start, which is making sure that hey, bring down the post size from 5 million to 2000. And once these posts are coming to 2000, then I can use my model to predict what post am I going to show and what post I'm not going to show. Okay, so this retrieval service does this part. Now coming to the next thing, that is it would do multiple things. It would even solve the problem of like it would help us in call start problem, where if a new user jumps in, so how do we take care of that? So if a new user jumps in, the work is that show him the popular post. Okay, show him the most shared post or trending post, something like that. And once this is done, then it goes to something like ranking service. Okay, this is where our model comes in. I'll just rub this part. See this ranking service is nothing but your ML model which we train. Okay, now this ranking service will have two things with it. One is your feature store. Okay, and second thing will be your online feature computation. So now online feature computation will tell, hey, the user is liking post, the last 5 posts with the user like is this. Okay, and feature store will be telling about the personality. Okay, and using both of them, these 2000 posts will be brought down to 100. And this ranking service will calculate scores for every particular post, and the post number is only 2000. So the time would be also really less. Now the time would be, so the whole stuff would be happening in less than 200 milliseconds here, because retrieval service is pure logic that is happening here, and ranking services happening only over 2000 posts. So the time decreases to so time is really less. And once we have this 100 posts, what we need to do is, See, in this 100 posts, there could be posts which, let's say there is a user who likes posts posted by Virat Kohli, but it doesn't mean right, like we just show him the post which is just related to Virat Kohli. So we need some logic here. So after this ranking service, we can have a re-ranking service which will take care. This is again business logic. What it will do is, hey, if let's say in 100 posts there are like 10 posts which are related to a particular author only, bring it down to 2. Okay, something like that. Or let's say there is a post which has a lot of violence in it, so there could be a safety based filter that could be applied. Hey, don't include violence in these posts. So once this re-ranking service is applied, then we can see the top 20 posts or top 50 posts to the user. So this is how it works. And one more thing just to cover, the cold start problem. Let me try to tell you about the cold start problem here. So for example, if a new post is coming, whenever a new post is coming, first thing is that show it to small number of users, see the reactions on that. If the post is getting liked and comment and shares, it means that hey, the post has to be shown to other users. And once the post is retrained, it will be eventually pulled to the embeddings closer to the other post embeddings which are similar to it. Okay, so this is one thing. Then for new user, whenever a new user is coming, okay, the first thing is that the retrieval service, what it's going to do is that it's going to show popular post, the most commented post or most shared post. And once the user likes and comments over it, then we are going to eventually retrain our model every other day. And once this is done, we will eventually see that hey, what kind of post does the user likes. So this even solves the problem of cold start problem as well. So yeah, this was majorly about this system design problem of newsfeed recommendation, personalized newsfeed recommendation system. Thank you.